All right, so first off, happy Halloween. Right, it's Halloween. So we celebrated last week, so we don't need to do like a big old thing at school today since we did it last week. But happy Halloween. Hopefully you guys go and get some free candy tonight. We were having a big debate last week on how old is too old for trick-or-treat, and I totally believe that 7th grade is still within plenty of age gap. If our decision came down to if you have a good costume. You can't just go out and be like, I'm a football player when you actually play on the football team. That's lame. You got to dress up. So, progressing to mastery for this test, either in your plan book, in your to-do list, or on your mastery. If you have a progressing right now, I need you to write this down. P to M. And that's kind of like the code that I use. If you need to go from progressing to a mastery, so I'm waiting to see pencils moving because I know that a lot of us are progressing right now. Now, the revisions were like step 1. We're like, let's fix this, let's get corrected so we know what mistakes we made last time. So, still, the grade you have on your test that's circled like in my pen is most likely a progressing. That's okay. We all made some mistakes. It's okay. Progressings are okay. For this chapter, to go from progressing to mastery, you first, sorry, I need to reorient my smartboard apparently. Number 1 is going to be revisions. So if you want to have everything written down, you can go ahead and write that down, although most of us already have that done if we were here. If you do not have revisions done, or you somehow missed a question that you had, should have revised, first things first is revisions, and there's a video for that. So revisions is corrections, right? And there's a video on our YouTube channel from last Friday, I think, when we did that. Number 2, this chapter. So I want to see how this goes. I'm still kind of experimenting with you guys. You're like my guinea pigs. Is to make up new problems. So please write that down, and then I'll explain what that means. Make up new problems. So if I, let's say, missed number 2, where I graphed it wrong, and I had my axes incorrect. Number 2 dealt with time since the beginning of the game and people at a concession stand. So maybe if I start thinking about a new problem for number 2, I want to create a T-chart with my own data, and you're making this up. So you can really make this as easy as you want. So I can make a T-chart, and I now know that time has to be my x-axis. So time since whatever, maybe since the beginning of the canteen. And maybe this is number of people. What could we say? Number of people like Alex? In the, well, we don't really have like an auditorium, but like in the dance. Let's say number of people dancing. I know that when we started, like when the canteen had just begun, 5 minutes into the canteen, I had like nobody dancing. There were like 3 people dancing. I'm just making this stuff up, right? 10 minutes into the canteen, maybe I had 15 people dancing. Maybe 15 minutes into the canteen, I actually had like 40 people dancing. Maybe my data is going to get bigger than it was before. And then you graph it. You copy, you essentially make a new problem from what you missed with just new numbers. If you missed, and a lot of us missed, number 8, look at number 8. So that was a mixed number times a mixed number. Just make up whatever you want. So I could say like 2 3/5 times 7 9/14, or whatever you want. 2 mixed numbers show how to multiply them. You make it up. You can make it easy, you can make it hard. Show 2 different ways. Does it make sense what you're doing? You're making up new problems that match it. Now, if you need help making up those problems, talk to a peer, talk to me, talk to Mr. Smith. We will help you, but I want you to practice in your own brain, how do I set up a problem like this? How do I solve through it? How do I check that my answer is correct? And then that's going to make a little bit more work for me, because it's not like I'm going to have an answer key, but I want to see how your brain's working. Hanukkah? Probably just redo it, like make a note, or come see me, and we can chat about it, and we can maybe talk through the problem on our own. Sometimes, if you come meet with me, actually a lot of times if you come meet with me, I'll just mark it off. Like, you will end up not having to write anything or as much. Like if we talk through a problem, a lot of times I'm doing it on the board, you're telling me how to do it, and then I know that you know what you're doing. It's about knowing that you know what you're doing. Yes, you may do this with a partner. So if you and a partner, you and a friend miss the same problems, you can make up the same problems. You can do it together. Work together. I'm totally all about that. Are there questions on what is expected from you? I guarantee somebody's got a question. Because at AO today, I'm going to have somebody come to me and say, wait, I'm confused. Nobody in here is confused on how to go from a progressing to mastery. These grades are going in math at my planning period today. So this is not something like, oh, maybe I'll do it next week. Like, it's going to be in math. Okay? All right. File that away wherever you put things that need your attention if you have a progressing. So if you want to put that in homework section, this is kind of like your homework now. If you want to put that in your math section, if you'll remember to go back to it, you may. Up to you where you put it. Then when you come to turn it back in, I need to remind you guys of something. You always place your papers, give me your eyeballs, give me your eyeballs, give me your eyeballs, with the bin, the direction the bin faces. Anything sticking out of the bin means it needs to go back to you. That's my little coding system. Normally I keep it in a clip too, but when you put your paper in here, just put it in facing with the bin. Okay? You guys are always the top bin here. So whenever you get your revisions done, turn them in. So if you get them done at AO today, your grade could change pretty quickly. You wait a week, that's going to sit there as a progressing. Please make sure you have your homework written down. If you don't, it's still over on that board. Today we're in 323, so please, a couple books at your table group, please go to 323. And we are eventually going to need the integer tiles today. You guys ready to catch?
Yeah.
Can we do this?
I got this.
Oh, yeah. Matt? I had to make it at least a little difficult. I went beside your face. I didn't go, like, world-class softball pitch. Anyone play softball in here? I'm super impressed by softball pitchers. I think it's, like, weird way that your body works. So, in this lesson, yesterday you worked more with additive inverses, right? How was the sub, by the way, yesterday? It was good? Was he a math guy? Was he actually? I didn't even get to meet him. Who, what? I mean, most of the time math people would want to pick this up, but sometimes they just pick it up because they want to pick up the job. So in this lesson, we're going to work with our team to continue thinking about what happens when we remove positive and negative. Remember, we're not calling them plus minus. We're calling these positive and negative tiles from a collection representing a number. We'll extend this thinking today to make our calculations more efficient. What's it mean to be efficient? Yeah, Liam? Not necessarily fast. You can have an efficient process that takes a while. What does it mean if they say, like, this dishwasher was made with, like, to be high efficiency? That doesn't mean it's, like, instantaneous. Alex?
It works well.
Yeah, it works well, Annika. There's, like, no waste, right? So no waste, or, like, being efficient means not necessarily to work fast, but we work faster than we could. So there's a long way to do this and a shorter way to do this, and we want the shorter way. That's what it means to be efficient. So we're going to ask ourselves, is there a more efficient way to do this? And how do these ideas compare with what we learned about adding and multiplying integers in Chapter 2? So I want your team to look at 351. And you can use the integer tiles if you need, but talk with your team about, are we able to do, I mean, obviously, we're asking you to do it, so we probably can do it. But could we physically do it? Or we have to do something else in order to physically do it? How do we get to this answer? So take at least 3 minutes and look at A through E. See if there's any of these that could be rewritten in a more efficient way. And really, we're not caring too much about the exact result. We'll talk about the exact results. What we're really talking about, will my value get bigger or smaller than it started? Now remember, bigger negative is still smaller. So give me your eyes for one more second, then I'll let you go. Negative 2 is bigger than negative 20 because it's more positive. Bigger values are higher on the number line. So negative 100 is smaller than negative 10. Make sense? That throws people off. So to dive into it, we'll give you at least 3 minutes to look at A through E on 51. So when you think about A, it just seems really quiet in here. And you think if I start with a negative 1 and go to take away negative 6.5, can it be done, quote unquote? Could we physically start with one negative tile and take away 6.5? No, we don't have enough negatives. Who can be so bold to explain to us, so we remember why this process happens, what we actually do here, if I can't take away that many negatives? Liam, what do you think? What do I do when I can't take away negatives? Or I don't have the negatives to take away?
Well, make them.
So I'm starting with one negative, right? And I want to take away 6.5 negatives. I can't. What do you mean make? I can't just do, I have negative 1 to begin with.
Add 2 of the positive.
Everybody talk with your group. There's a candy prize for whatever group can tell me first what we need to do. Because this is really frustrating. We should know this. We've done this multiple days. You can't tell me. Somebody else from your group has to then. If you're raising your hand, everybody from your group would have to be able to tell me. I will ask a random person from your group. I'm not going to take what hand is up. I'm not even going to let hands factor in. So here's what's up. Give me your attention for a second. You have 90 seconds to talk with your group. At the end of that 90 seconds, I'm going to call on a random group. If whoever I pick can tell me how to solve this problem, your entire group gets candy. If not, I move on. 90 seconds. Go. What out of it is opposite numbers make 0, right? I don't really see opposite numbers. I see a negative 1 and then take away a negative 6.5. I'm not saying you're wrong, but you got to be able to explain. Okay, I'm just pushing it.
Can we add stuff to it? Like, you know, it's like nothing.
You're not allowed to add anything, but you can add nothing.
What?
Yeah. 10 seconds.
Wait, hold on.
And time. Mr. Hopkins, there's only 3 people in your group. That'd be less candy for me to give out. Do you know what we would need to do here?
Don't you turn, wait, don't you add them?
What do you mean?
Don't you add, 1 plus 6.5 or something like that?
It's asking me to take things away. Why would I do that? You're asking me a question, but I'm asking you for an answer. I'm not saying you're wrong, but I'm asking why. Allie, do you know? You're looking at me like you got more info.
I'm not sure. I'm just gonna try and think about it. But I just have random things going through my head. But I feel like adding it would be making it more negative than it is.
Ooh, depends on what we add. So I do like, yeah, because you're kind of going off of Alan's thought of if we add.
Don't you add 6.5 to 1 and then it cancels out?
But why? I will agree that this will turn into addition. When we see minus a negative, it turns into addition. But the why has yet to be answered. The physically what I can do. Leah?
Is it,
Everybody on your picture, right, or on your picture, in your toolkit or your notes, wherever you're at. Liam, I'm coming back to you. But to make sure that we all have this, everybody write this problem out. -1 minus -6.5. Write it out big. We're going to give ourselves some good space for this in our notes. -1 minus -6.5. Write it out. Write it out. Then draw your mat, your workspace. We start with a -1. We are trying to take away negatives. Liam, can I do that? Can I take away 6.5 negatives? Not with what I have. Do you know what I need to do in order to be able to do this? We add nothing. What we do with this problem, everybody needs to model this. I'm going to check this when I check your math journals next time, because this is killing me that we don't know this. We can bring in 0 pairs. So really big, somewhere on your paper, write 0 pairs. So I bring in a plus and a minus, but that's really 0. And I put in a plus and a minus, still really 0. Another plus and a minus, 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 until I'm able to take away 6.5 negatives. When I look in my box right now, still, what is the value that we're starting with? Alex? Still -1. But now, can I take away 6.5 negatives? Yes. I, wherever I left it, with my red pen, can show, well, here's my 6. Here's a half. Right? All of this comes out. So the minus 6.5 negatives is what we just did. But what we're left with, you modeling this with me, Ella? What are we left with inside the box? Don't tell me the number. Tell me what we actually physically see. Yeah? Half of a negative and and all the positives. 6 of them, right? Now when we put that together, what is the end result of what's left in my box? Negative? Close. 5.5. Because this half negative will take away half of a positive. Kind of hard to show half of a positive. So I end up with 1, 2, 3, 4, 5 positives and a half positive left over. This is what we need to understand. You cannot just say minus a negative makes a plus. You can't just like be a robot. You got to know why. I promise you. Give me your eyeballs so I know we're all listening. I promise you, on your next mastery assessment, which I'll probably do a little quiz on Friday, showing this will be part of it. I promise you. Please, if you are confused with what we just did, stick up a hand right now. I'd like to answer questions. Where's your confusion? Can you articulate a question?
I'm just confused about all of it.
What do you mean?
I don't know. It's just confusing.
So I like using the integer tiles, but I think sometimes just working with those is doesn't like let us have enough written down. So let's move on in your toolkit or wherever you're taking your notes and write like 51B or however you're coding. We're going to write this problem down. So write that down in your notes. 2.2 minus the negative 2.2. B. Yeah.
I just don't really get the point of cropping it all out, like writing it all down. Even though we're not technically able to do -1 minus -6.5, if you take away the negatives, you would still just get 5.5.
Well, why are you allowed to do that?
Well, really, you're not allowed to do the same answer.
No, you can't just say you're not allowed. And like there are rules that we have to follow, and there are rules that, like, there are rules we have to follow, and then things we can do because there are no rules about them. But there are very strict rules about working with expressions. You can't just take things away because you don't because you can't do it. So the reason why we're doing this is so you can explain the why. Guys, I will tell you, by the time you graduate high school, you should have a better mathematical foundation than anybody over 20 years old. And Mr. Smith is back there nodding in agreement. How us adults were taught math, we got the short straw. We got gypped, we got ripped off, we got whatever you want to say, we got a raw deal. Because we were essentially handed the memorize this, memorize this, memorize this, and if you asked why, get your hand smacked with a ruler, and they'd say, you don't need to know why, just know it. Not always for real, but if you went to Catholic school, a lot of times they would smack you against the ruler. We want you to ask the why, and we want you to understand the why. But if your brain's not engaged, and you're like, well, we can just like do... No, you can't just do things. You have to follow mathematical rules. The reason why this will become a plus has to make sense to you. You can't just say, well, it's a rule. So, watch, then we'll model this out together. If I somehow can draw, starting with 2.2. So I'm going to draw my workspace. We're going to start with a positive. So I'm going to make positive chips. So positive, positive, and then a little wedge. So 2.2. Can you imagine with me that that's like 2.2? 2 and a tenth, like a little wedge. Can I take away, right? That's what subtraction tells me to do. Take away a negative. I have negatives to take away here? No. I technically cannot do this to start. So, what do we do mathematically? Kate's table group is already won. I'll open this up. Another table group can win. Alex, what do I do? Your hand went up first. Now be careful saying add. I bring in, I let that word ride last time, but I bring in, what do we call those? Yeah, what else did we call those last time? Shorter words, easier to understand. Zero pairs. So I can bring in as many zero pairs as I want. So if I bring in a positive 0 or a positive 2, I'd have to bring in a negative 2. Now still I don't have enough, so I could just bring in another whole positive and another whole negative. Now I can take away the 2.2 negatives. So we can 2 and a 0.2 take those away. Now if I took away that 0.2 negative, how much of this negative is left? If I took away 0.2 of it, 0.8. So now you have to look at combined what is left in our box. These got taken out, right? So those don't count. I have 1, 2. How many total positives? Just total. I can look at them easy. How many in my box? Patrick? 5 and these 2 tenths. Right? Because I haven't done anything with the negatives or any of that stuff. So I have the whole 5s and the 2 tenths. So I could say, all right, I have 5.2, right? But then I also have a negative 0.8, so that's going to bring my positive back down. So take that away from your positives, and what do you get? 4.4, which is what you would have gotten if you just add these, but you have to understand why. It comes down to 0 pairs. Having to bring in the 0 pairs, which leaves you with extra positives. That's why we actually end up adding positives. Because to take away the negative, we need extra positives. Is this making sense at all? I'm going really slow today, and I know that, because I want this to sink in. Try C with your group. You have positive, and you're taking away positive. Talk as your group. Can you do this? What would you need to do? Sorry, in honor of Halloween, I'm just going with the candy corn. When your groups are on and they're talking, it's potentially worth rewards every now and then. And today or tomorrow, I get to go buy all the discount candy, so then I'll have more candy. Group I haven't really talked to. Marvin, Ella, Zoe, somebody back there. Can I take away, let's forget about the fractions for now. Can I take 22 away from 12? No. Quote unquote can't. Right? So we know something interesting is going to happen here. What could I take away from 12 and a half? Ella, do you know? If I start with 12 and a half, how much can I take away? I can take away all of it, right? So I could take away 12 and a half. How much more would I need to take away? If I break this up, I take away the 12 and a half first. Well, there's going to be 10 more to take away. This answer will end up being negative 10, but there are a couple ways that we can get there. The other thing we can do is instead of minus a positive, we can rewrite this, and I would like you guys to rewrite this on your paper. Minus a positive can be rewritten as plus a negative. if we started with 12.5 positives on our mat, and we bring in 22.5 negatives, we get all the canceling that'll happen, and we get left over 10 negatives. Because we could take away 12.5 of them, but then we would need 10 zero pairs, and those positive 10 would go away, leaving us with negative 10. Questions? We're taking situations we can't do and figuring out ways that we can. Indeed. Go ahead and write this down, please. Negative 100 minus negative 98. Anyone talk this through for me? You volunteers? I'm still trying to make my way around here. Matt, what about you, dude? If I start with 100 negatives, can I take away 98 negatives? Yeah, this one we can do. Still, though, think about it like this. If minus a negative is actually plus, because if you understand why, we can start to just apply the rule. If I have 100 negatives and 98 positives, which one wins? Which one? So the negative, right? By how much? How much stronger is it? It's stronger by 2. No? Nobody? Come on, don't write this down. Don't write this. It's wrong. It's wrong. It's stronger by 2. It's negative because the stronger value was negative. Always think about if your answer makes sense, and be aware I write wrong answers up here sometimes on purpose to see if your brain is actually turned on. A lot of times if you're the one to catch that, there's candy involved. If I have 100 negatives to start and then take away 98 of the negatives, we are left with 2 negatives. This should make the same sense in your brain as if I have 100 negatives and I drop in 98 positives. 98 zero pairs will happen with 2 negatives not able to pair up. These would be the same thing. Visually, we might do it differently, but it activates the same way. Questions? Now, E. I want to come back to E in like a minute. You, as your group, talk about E. Is there anything in E that can make it more efficient? Question? So how do we do it more efficiently? Or negative plus the most efficient way to do it, like adding them. What do we do when we repeat addition or subtraction? Like go 5 plus 5 plus 5 plus 5 plus 5. That would be most efficient. So how many times do we do that? 20 seconds, we'll come back. Stop that. So Nathan called me over and he said, "Hey, I know the answer. We just take away the 2 negatives and we get -4." I agree. But then I pushed. And I said, what's the most efficient way to do this? So Nathan, what'd you end up on? What do you think's the most efficient way to do this? So we look at this and we say, well, this is happening 3 times. What is it that's happening 3 times? You want to keep rolling? What is happening 3 times? Yeah, the -2 being taken away from the -10. So we start with -10. And then take away, please rewrite this with me, rewrite this in your notes. How many groups? 3, right? Take away 3 groups of how much? Of -2. Take away 3 groups of -2. Which when we look at, well, what will 3 groups of -2 actually be? Well, how much is 3 groups of -2, guys? -6. So we're really taking away -6. And when we take away the negatives, my answer goes towards 0 because I'm getting rid of negative value. So then we say 10 minus 6 because we go towards 0. My answer will be -4. Questions? Are there any questions left over from yesterday's lesson? Things that didn't quite get covered well enough? I'm going to pull it up and scroll through it so that might activate your brain. We are going to essentially, most likely make this more of like a 2-day lesson task. We might try to get through this plus tomorrow. What I want from you mainly tonight is to work on this homework and make sure you have last night's homework done. I really want to take homework questions tomorrow if there are any. Now, for that to work, you have to have tried the homework. You have to at least know what questions you have. I will get answers posted on Schoology, just like we did last week. I'll get answers posted here during my plan period. But from yesterday, 322, we got about 5 minutes left. Are there any questions left from things you guys did yesterday that didn't make sense? Yeah. 340. There isn't really a part. 348. Oh, 348. So this is saying figure out the length of the acrobat's trick. Now, what we know about if this is x and that's x is they both must be the same thing. So I say I jump a distance twice and have made it 7 feet. How far was that distance? Now, this would be easier if I break it down and make it simpler. What if I jump a distance twice and made it 6 feet? How far is each of those distances? Yeah, so then if I go 7 with those 2 jumps instead of 3, 3.5, right? So this will be 3.5 because each of these has to be equal to make that total jump of 7. Other questions? So I know some of these hands that are still down are probably because we didn't try the homework. Please make sure you get last night's homework done. Try tonight's homework, and we'll take more questions tomorrow. I still can't really dismiss you because we still have just a couple minutes left. So, and where we're headed tomorrow, yeah, it's not really worth talking too much about it. You do not have to make it all the way through the homework tonight because we will probably make that a 2-day homework, but try to so that you're constantly trying to work ahead. I will just go ahead and let you guys go for today. Please try to be here on time. I know it's hard after Creative Start, but we really got to use those first couple minutes of class. Please try to be here on time. Thank you very much. Have a good day, guys.